Hello everyone, welcome to Flip Flop Data. This is part 2 of Consumer Preference Model series. I have already covered how to develop consumer preference model using Excel in part 1 of this video series. So in this video, I will show you how consumer preference model can be developed using R language. Same case study is utilized as in part 1 with few changes in the captured responses of the respondents. So before starting, I want to convey that if you have any confusion in understanding, please go through part 1 of this video series to get a better understanding. So let's start with the case study of a beer manufacturing company. Suppose the company now plans to diversify into wine manufacturing, but beforehand wants to find out its consumer preferences depending on certain attributes or features. So, our product or service is wine. Number of respondents chosen is 50. See, number of attributes or the features considered is 5. Again, within each attribute or feature, there are certain levels or categories defined. So, number of levels considered is 3 within each attribute. So, with full factorial design, the total number of generated combinations will be 3 to the power of 5, which is 243, where 3 is the number of levels and 5 is the number of attributes, which includes both correlated and the uncorrelated combinations. So the design considered over here is the orthogonal design to avoid multicollinearity aspects. So you can well ahead see the screenshot captured which gives you the identified attributes and levels. So let us first create an orthogonal design using the listed attributes and levels in R. This is the screenshot captured. So expand.grid function is used to create all the required attributes and its levels in R. Once attributes and its levels are created, conjoint package is used for further calculations. So if you don't have the package installed, then please first install it using install.packages function and then call the library conjoint. So once that is done, function CA factorial design is used with type chosen as orthogonal to create uncorrelated combinations. Then the function CA encoded design is used to create numeric code for the attributes and levels. So once this is done, you can actually save this output in CSV or XLS file as per your need or requirement. So these are the 13 orthogonal combinations which is generated from the earlier depicted code. And see, if you use the full factorial design, the total combinations are 243, as I told you. So from that, these 13 uncorrelated combinations are generated. You can see 17, 20, 21, 34, going till 241. So these are the 13 orthogonal combinations which is generated from the same full factorial list of 243 combinations. So next, what do we do here is checking for multicollinearity amongst orthogonal combinations. So function core is used to compute correlation. So this shows basically correlation as 0 for each attribute. You can save this file again as CSV or XLS as per your choice. So these generated 13 combinations are shared to each of the 50 respondents for capturing their responses on a scale of 1 to 10. So same has been depicted in this screenshot over here. Then next is performing linear regression on the collected responses. So how do we do it? The consumer preferences response, which is our input, is read into RStudio and is saved into consumer response variable. Then next is encoding of each of the levels within each attribute as per the required code, and then converting these into factor variables. So European is represented as 1, Canadian as 2, Japanese as 3, and similarly for all the other attributes and levels, it has been done like that. So our pre-processed data is now ready for computing linear regression. So linear regression is run using function lm, and it is captured in consumer response model. So just by looking at the summary of consumer response model, we can make out the importance or preference of the consumers. So this table captured depicts basically that our consumers are highly sensitive to price, then origin, and then calories. Now next is finding out numeric importance of each attribute. How do we do that? So we make use of rela-impo package for computing importance and preference. If the package is not installed, then please install it using install.packages function. And then you can call the library rela-impo. Once this library is called, then function calc.relimp is used to compute preference, where consumer response model generated by linear regression is chosen as the main input along with type as LMG. LMG specifies which kind of metrics we want to generate. So once this is done, we run relimp at img, which gives the importance or preference of the features. So looking at this, we can easily identify that price per unit is most important. Then comes the calorie. Third is origin. And aftertaste and glass is the least important for consumers. So there is a bar plot also for better visualization. This also depicts the same result, that consumers are sensitive to price, then calories, then origin, and aftertaste and glass is least important. So this turns out to be a great way to represent consumer preferences, helping the sellers and marketers in devising their strategy for their new product or existing enhancement. So with this, I conclude my second part. Please post your comments and queries in the comment section and I will be happy to respond. Also, if any one of you is interested to get the full template, then please let me know. Thanks for watching. I will see you all in my next video. Don't forget to subscribe.